let's discuss asymmetric systems. Asymmetric encryption is the other side of the coin. Where we've talked about symmetric, let's now talk about asymmetric. The asymmetric encryption uses the same password for encryption and decryption. So if the file has to be decrypted by someone else, not just sitting on your machine where you will know the password for both sides, how do we get the password to this other person? And that's a big problem in encryption, that we want to be able to distribute everything that we need to do with the processes securely. So we could send it in the same email, really bad, because it's something that's going to be both sides of the solution, padlock and key, both in the same message. We could send it out of band, perhaps in a separate email, call them and tell them with a phone, or send them a text message. But imagine if there were 1,000 other people. We've now got a situation which is impossible to scale and is hugely impractical. We can't possibly text 10,000 different people every time we need to do it. So a system has been invented called asymmetric algorithms. And the way in which they work is that an asymmetric algorithm has two keys. One of the keys is public and one of the keys is private. Now, there are several versions of asymmetric algorithms that you should know about, even if you just know their names. Now, because of the unit that we are studying, I've put the first one at the top of the list. Now, these systems that are used, all based on complicated mathematics, basically on prime numbers, complicated, very large prime numbers, the sum of the two prime numbers, all sorts of different systems are used. And the one which we are principally interested in is RSA, Rivest-Shamir-Alderman. And that's the one that uses primary numbers to work out the key. And then we get elliptical curve cryptosystems, and that's based around the complicated mathematics of a curve. Then we get Diffie-Hellman and L-Gamma. If you can remember one other name of one of the ones, but definitely remember Rivest-Shamir-Alderman, RSA, and one other, and you'll be fine for what we need for our unit. Now, there's a system called asymmetric algorithm, and they use a public key and a private key, as we've just said. And what's really important for you to understand is that both the keys must be generated at the same time because they are mathematically related. Both keys must be generated at the same time because they're related to each other. And the second thing that's really important to remember is about how these keys can be used. If you encrypt with a private key, you need to decrypt with the public key. If you encrypt with the public key, you need to decrypt with the private key. That's just a rule. That's the way that this system must work. So that's what the introduction to these asymmetric keys is about, that you've got two keys and they're used in different ways. Now, we're going to talk about the usage in the next one, so hold on to your hats and we'll get there very soon.